So as mentioned, my name is Kaspars Liepiņš. I work at the Freeport of Ventspils, where my job is to develop a green energy cluster, which is a polite way of saying that my job is to help an old port to become a new one. This is the first of the MarTe Soft Skills Webinars, and today I want you to talk about something that the marine and maritime community across Baltic is living through right now. The end of the one business model and the beginning of four others. The talk is called Ports of Tomorrow. All right, so let me, So what you are looking at is a total cargo turnover for the four big Eastern Baltic ports, Klaipėda, Ventspils, Riga, and Tallinn. From 2005 until 2025, that's 20 years span. Millions of tons per year on the vertical axis and 2 decades on the chart. Look at the three of these ports, Riga, Ventspils, and Tallinn. They peaked somewhat between 2006 and 2014, and then they declined. Tallinn fell the fastest. Ventspils, where I work, has gone from around 30 million tons at its peak to under 10 today. Riga is roughly half of what it was. Only Klaipėda kept growing, and even Klaipėda has come off its 2020 peak. The headline is very simple here, and it's uncomfortable. The transit hub era of the Eastern Baltic is over. It's not paused, it's not a cyclical dip, it's structurally over. And that matters because for the 30 years, that one business model, how these ports made their living and their income. So the headline numbers hides the real story. When you break each port down to the cargo type, you see what is actually lost. The dark band on each of these charts are the fossil transit. Russian crude, oil products, Russian and Belarusian coal. Klaipėda always has been a more balanced mix with more containers and Ro-Ro, so the other three were heavily exposed. For Ventspils, the dark band used to be roughly 2/3 of the port. Now it's close to zero. For Tallinn it was a quarter, and the quarter is gone. The ports did not lose a percentage of their business, they lost the foundation of their business. So the question is no longer whether something has changed. The question is what changed it and what comes next. There are several pressures. Pressure one is a geopolitical shock. Russian and Belarusian transit volumes, coal, crude, oil products, fertilizers are gone, or they are going away. Sanctions, railway routes, pipeline closures, EU policy of energy independence, these are not the temporary measures that will unwound when the war ends. They are the new map, and the old throughput models cannot simply be replaced with one of the same cargo from somewhere else, because the cargo that filled those terminals does not exist on the European market anymore. It's gone. Exactly the same time, the pressure two is hitting us, and this one is a regulatory, not existential. Fit for 55, minus 55% in the greenhouse gas emissions by 2030. The IMO net zero target for the international shipping by 2050. Clean Baltic Sea shipping ambition of 100% shore power availability for the vessels at the berths by 2030. And if you layer on top of that, we have EU funding, the Innovation Fund, the Connecting Europe Facility, Interreg. It's flowing to the ports that pivot and bypass those that do not, that are sitting at their existing grounds. And now let's stop and feel a bit of the squeeze. The same ports that lost their own business are being told by the Europe and their own ship owner customers that they must build a new one. On the same keys, with the same balance sheet, with the same people. That's a position the Eastern Baltic finds itself right now. And that is what the rest of the talk is about. What the new business actually looks like and how we can potentially build it. Here is a thesis of the talk, and I will distill it into the several next slides. The pivot is not about finding one new mega cargo that replaces existing transit models. There is no single replacement. The pivot is about layering 4 new revenue streams on top of the infrastructure that is already there. And I'm talking from the model of the Ventspils we are working now and looking into. First, the port becomes a renewable energy hub. Wind of the port on the port hinterland, solar on the idle land, battery storage on grid-connected land parcels, and the industry yard for the offshore and onshore wind value chain, a turbine pre-assembly, blade storage, service vessels. The port stops being a transit node and becomes Latvia's industrial energy yard. Second, you stop exporting the renewable electricity in raw form and start exporting it into the molecules. You convert it into the hydrogen, into the green ammonia, into the e-methanol, into sustainable aviation fuel. The port becomes a chemical factory that runs on the weather, on the conditions which are enabling the renewables. Then there's a third one. Some of those molecules never leave. They become a bunker fuels for the ships that pass over the coast. Methanol, ammonia, hydrogen. The port plugs into the green shipping corridor that the Baltic states are building between each other now and across the Baltic Sea as well. And of course, none of these 3 works without a digital backbone. Digital twins, AI-driven berth allocation, on-berth power system, electrified cargo handling. This is a platform that makes 3 businesses run, and it happens at the most to be one of the most exportable skill set the port can develop. And once again, we have the same keys, same hinterland, 4 new businesses. This is the model. And let me now you walk through each of the sections in the next slides. This is what the green energy cluster in the port Ventspils look like when you sketch it in the out. We have a wind on the hinterland, solar on the portland, battery storage to firm the supply. We have electrolyzers turning the power into the hydrogen, ammonia and methanol plants and tanks at the quayside. Biofuel feedstock from inland Latvia, hydrogen and CO2 at the ships at the berth. And the electrification cycle into the local grid through high voltage lines, which we call the Kursam looks. Every box on this drawing corresponds to the project that is either operating, contracted, or environmental impact assessment is ongoing. So let me show you in the details. 86 megawatts of onshore wind is installed in the Ventspils region today. 370 megawatts more is planned and going through the permitting. 1,552 megawatts is on the environmental impact assessment, so we need to see how it progresses. And then we have, of course, the larger projects like Elwind, which is the offshore joint Latvian-Estonian wind project. And well, altogether it can be up to 2,000 megawatts or 2 gigawatts. Round numbers, roughly 4 gigawatts of renewable energy supply within the reach of the port. That is bigger than the entire current Latvian electricity peak demand. Add solar ready land parcels right next to the grid. The country first battery storage system operational already in the port since 2024. 10 megawatts and 20 megawatt hours from utilities wind. On domestic feedstock of biofuels in operating biofuel plant in the port already for 15 years. We have a raw material and everything what is needed to create this business model. Wind is the easy part. The more interesting part is what you do with electrons once you have them. So let's focus on those. For those who are into the map views, I will show a little bit on the wind. Every cross on there is a wind turbine. Every yellow area on the map is an environmental impact assessment. And the small icon bottom left on the map, that's a Elwind project location. And Ventspils sits in the middle of it. The wind is generally there already and in a pipeline of being built. This is what the second business looks like in a project, written in a project. We have one ongoing project, which has, of course, its all struggles, and we hope that it might succeed at the end of the day. It's a project of green ammonia. 52 hectares of the port land has been leased to develop the green ammonia plant. Project's name is Ventspils. The plant capacity is 67,000 tons of green hydrogen per year, which is converted into the 67,000 tons of the green ammonia supply yearly. And we anticipated an investment can land somewhere north of the 1.3 billion euros. Currently, the environmental impact assessment is underway. We have the feasibility study already performed, and the signals are also real from the market. There is a memorandum of understanding for the sale of ammonia concluded with a German trading house. So that means that the product has an off-taker before the first foundation is poured, and that's very important for this type of the business. The reason ammonia is a lead molecule is that, unlike the hydrogen, ammonia is shippable today. And the port has 50 years of the handling history. The tanks, the safety protocols, the trading houses, they all exist. Green ammonia is how the renewable electricity from the Eastern Baltic can get into the ports of Hamburg, Rotterdam, and Japan on the longer shipping routes. And you cannot run a wind and solar cluster without storage. Latvia's first and largest battery energy storage system, 10 megawatts of power, was built back in 2024. And with more than 7 million euros invested, it's operating in the Ventspils region already solidly, and also proved to be like a first testing ground for the grid connection and protocols. And there was quite a learning curve for the developers and also for the rest of the region. And we have other projects as well announced, so we hope that these projects will materialize and will move forward, and the energy storage will become an integral part of the port hinterland and surrounding area operations. The port has also 1.6 million cubic meters of liquid product tankage and tank farms on the site. It's, I think, one of the largest storage sites in the Baltic Sea. There is an existing ammonia handling terminal with roughly 1.5 million tons of the annual ammonia throughput in the past, in heydays of the Russian transit. And 2 tanks of capacity of 54,000 tons of the storage. We have 2 further feasibility studies ongoing, one for CO2 export terminal with a pipeline to the port, and the other one for the green methanol, biomethanol plant of up to 300,000 tons per year. And this is a part of the story I want you to hold on. So the tanks, the pipelines, the jetties, rail connections, and the Treinig wharf course, they were built for the fossil cargoes, for the fossil flows, large volumes of the flows. And now they are being reused for the green molecules. The asset is the same. The product only changes. And that is the cheapest energy transition you will ever finance. You have already the bulk of the assets there. So, and those are not the artist renderings. These are the photographs from our quays. Onshore wind turbine blades, nozzles, and the tower sections are being handled in the Ventspils port right now. Stena, our port operator, is one of the most valuable, I think, suppliers of the onshore wind industry in Latvia. What you can see here is the development of the latest wind farm in Latvia, close to the city of Jelgava, and all of the large-sized components were shipped through the port of Ventspils and supplied into the middle of the Latvia to build this next-generation wind farm of large 6+ megawatt turbines. And what we also hope that once this import and supply of the wind value chain will turn also into the development project, the new terminals at the north end of the port, our vision, how it can look, is depicted here. And it's designed specifically to assembly and produce offshore wind turbines and onshore wind turbine parts. That moves the port from the we can ship blades to the we can build the whole turbine here. And that is the difference between being a logistic customer and being the industrial supplier. And the port has ambition and willingness to step into this area. And if you want to look for some technical details, we are targeting 40 to 50 hectares of terminal land, which will be reclaimed from the sea, 600 meters of the quay lengths, and around 100 hectares available in the hinterland to build the larger manufacturing sites for the large scale and large size components. So, yeah, these are the indicators that Ventspils can meet potentially within the investments supplied and the partners, right partners found. We can meet the wind industry demand and build these facilities. And yeah, so one more thing we are actively working on is also looking for the future models, and producing green ammonia in Ventspils is not just a chemistry. You turn it into the fuel business, and there are more things which are needed. There are customers, there are bunkering protocols, there's a corridor. And that's what we are now involved with an Interreg Baltic Sea region project called H2 derivatives at Baltic Sea ports. And we have 15 partners in the project, 7 Baltic Sea states, mainly port operators, 2.86 million euros in funding, 36 months of execution. And we, as a port of Ventspils, lead the work package 1, which has 2 subtasks, which means that we are working on a GIS-based mapping of renewable potential across the region. We're evaluating also the power-to-X pathways, how we can make and convert the electricity into the molecules, hydrogen, ammonia, methanol, eSAF, synthetic natural gas. We are identifying the spatial and technical constraints, grids, land availability, key storage, and produce investment cases with standard metrics: annual energy production, levelized cost of electricity, levelized cost of the molecule. These are the metrics you can go and talk and reach out for the potential investors and project developers as a port authority and involve them into the new business creation. So there are also 4 work packages which work on demand analysis at the ports across the Baltic region for the shipping industry, bunkering guidelines, the standards for the bunkering. Some port of Klaipėda is working on the bunkering vessel concept for methanol, and also tractor ship model, which is developed by our Estonian partners. And the regulatory framework is for safety manuals, and the public communication materials is also a key part of the project development. And there's a bit of the insight how this tool looks, what it will give in the hands of the port authorities and in the hands of the regional port cities and the port regions. You will be able to calculate your economics of these models and convert them into something which the investors and the developers understand: the money flow, the cash flows, the cost, the capex investment, the opex costs. So these are all vital things when you want to really engage the business and the industry in coming to your port and developing these assets. And I have spent the last 10 or 15 minutes telling you about how it looks and how it works, but I want also to indicate that there are some reasons why it might not work, because there are the barriers which exist, and this is the fastest way to fail if you don't see these barriers and don't act on them early on. So one barrier is capital intensity. On a single onshore power bears cost multiple millions of euros. We are building one now for the Stena terminal, and we know the costs. The green ammonia plant is north of the €1 billion investment. Without the risking these instruments, with the public guarantees, contract for difference on the product, on the molecules, anchor off-takers, these business cases stalls before the first money is invested. So this is the number one barrier, and it's not a technology program. It's a financial architecture problem, so which is key to address in early stages. 2, standardization. Shore power voltage and frequency and the plug standard still differ across the global fleet. Hydrogen derivative bunkering protocols are being written as we speak. They are not something common for now. And every port builds to slightly different standard. Every shift owner has to install a different piece of equipment, and the whole system fragments. So we solve this through the regional coordination. Exactly, that's why we have this H2 Dairy and MarTe project to some extent to standardize the things and make them easier to design to and use in the ports. Then we have a third item, the chicken and egg problem. Ports will not invest in the bunkering infrastructure without confirmed vessel demand. Ship owners will not retrofit their fleets without confirmed port availability. Both sides wait, unless someone moves first. And the role of public port authority, in my view, is exactly that. The first, to move the first, and to make the first move bankable for the people who came after that. And this is not an easy undertaking for sure. And the fourth is a grid headroom. If you run the onshore power supply, electrified cargo handling, or large-scale electrolyzers concurrently at the same port, you will load the local 110 to 330 kilowatt network harder than it has ever been loaded. And that's not a future problem. We need the grid impact studies for the port clusters already now, not in 2030. So because grid reinforcement takes longer than anything else in this story, how can we get to this next business models? So for the 30 years, the Eastern Baltic ports made their living moving cargoes from east to the west, from Russia to the Belarusian hinterlands to Europe and global markets. That direction is closed. We're opening in place a north-south axis. Renewable energy generated in the Baltics, converted into the molecules at our quays, at our land, is sold as a green energy into the rest of the European Union and beyond. The journey in 4 words: transit, then generation, then manufacturing, then bunkering. This is a sequence. This is not an order. None of these steps can be skipped. And if I could leave you with 3 practical asks, 3 things you can advocate for your own organization, your own ministry, your own research program, they could be these. So 1, the national mandate to invest, including the onshore power requirement and green bunkering support fund. So the first mover penalty becomes also the first mover advantage. 2, grid before fuel. Run the grid impact studies for the port clusters now, while there is still time to reinforce the grid supply. And the 3, pilot, then scale. 1 berth, 1 corridor, 1 offtake agreement proves it works, and then you replicate across the Baltic. And well, the next power plant we build in this region might be genuinely a port. And I want to finish my presentation with one vision from a port, which is also at the entry of the Baltic Sea, Port of Gothenburg, to illustrate the whole value chain in one short video.
We are the Green Connection. We aim to be the world's most sustainable port and recognize that the transition to a fossil-free society must happen, and happen fast. So we act now. But how? Thus far, oil has been the energy solution for most endeavors humankind has set its mind to. Sustainable electricity will replace fossil fuels in most areas of society, but in some sectors that isn't possible. In long-distance transport by air and sea, there will be a considerable demand for liquid fuel in the foreseeable future. Some industries might never transition to electricity. Each of these sectors have their own needs and circumstances. No one green energy can meet all those demands. So we must offer a range of solutions that suit our partners, customers, and society in general. There's a demand and we'll have the supply, but we can only find those solutions in close collaboration with our partners. Port of Gothenburg have the size, infrastructure, and the geographical location to be the renewable energy hub of Scandinavia. The Green Bunker Hub will supply sustainable fuels for the marine sector. We will provide a wide range of fuels, and together they will make almost all marine fuel fossil-free by 2050. Our goal is to become the largest hydrogen hub in Scandinavia. Here, hydrogen will be produced at the in-port electrolyzers with the help of offshore wind and wave energy. But we will also handle a lot of imported hydrogen. In 2050, we believe society will rely on hydrogen, and Port of Gothenburg will play an important role in that system. There will be a need for hydrogen in production of future fuels, in transporting energy between continents, and for storage of energy reserves. Advanced biofuels are the future for long-distance air transport. Today, aircrafts and helicopters can fly with a 50% blend of sustainable aviation fuel. Our partners are building state-of-the-art biorefineries in the port. We believe that by 2050, the Nordic flight industry has transitioned 100% from fossil fuels. Advanced biofuel is also an important transition propellant for ships and cars. Third and fourth generation of biofuels are yet to be developed, and their potential is growing with green technology solutions. For a long time, carbon dioxide will be released in some industrial processes, so the capture and handling of carbon will be important in many years to come. We will facilitate a complete logistics chain from liquefaction plants to storage facilities, and by 2050 we will expect to handle about 10 million tons of carbon dioxide, an important way to reduce climate change. To be the green connection, the world's most sustainable port, we are transforming our energy port. Together with our partners, we are building state-of-the-art infrastructure so that we can provide the most sustainable, modern, and competitive solutions far into the future.
So this just assures that ports are alike, and we are thinking in the same direction, whether we're in Scandinavia and the Baltic countries. So thank you so much for the presentation, for your time and attention, and apologies for running this presentation over the time. Thank you.